Hi everyone, Dr. P here, and in this lecture video we will take a look at more naming of chemical compounds. So in particular we're going to look at binary covalent compounds. And here the rules are a little bit different. For one, we're going to be looking at two nonmetals. And we're going to name the first element first like it was a cation. And then the second element will be named as if it was an anion. Now we need to use prefixes to indicate how many atoms are present. So this is different than those type 2 binary ionic compounds where we could have multiple possible charges on a metal and we used Roman numerals to indicate what the charge was. Here we're going to use prefixes but the prefixes are going to tell us the number of atoms. And these are a Greek prefixes, numeric prefixes. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. So I'll get to some examples in just a minute. A couple of other little things here. We don't use the mono for the first element. And then also we will typically drop the last vowel of a prefix if the element name also starts with a vowel. So some examples could be CO2, and we would name this carbon, not monocarbon, just carbon. And then this is dioxide. Okay. So this is a case where we actually don't drop that vowel for the di. Typically it's just with like mono or hepta or things like that. So if it was like, heptaoxide, we would probably just say heptoxide. All right, CO2, carbon dioxide. N2O5 would be dinitrogen. Pentoxide. That's a case where we do drop that A. Yeah, so those are naming binary covalent compounds. Okay. Now, you do want to practice a lot of this, so I'm going to go over just a few more practice examples. And I'll also go over some examples of working the other way. I've given you the rules for naming compounds. What about drawing a structure given a name? Well, in that case, you can essentially work backwards, and I'll walk you through how you would do that. So let's look at some things here. Let's do all right. So here we have some compounds. Let's work on their names. First one here, NF3. Well, we look at that and say, oh wait, nitrogen and fluorine are both nonmetals. So this is going to be a covalent compound. So we're going to follow the rules for naming covalent compounds. So it would be nitrogen, and then fluoride, but we have three of them, so it's trifluoride. All right, next one. We have barium and oxygen. So this is simply barium oxide. And I can look on my periodic table and see barium is in group 2, and it only ever has a 2+ charge. Oxygen only ever has a 2- charge, so we don't need to use any Roman numerals. Next one here, CrO3. Now here, chromium, I happen to remember that chromium is in the middle of the periodic table in the transition metals, and it can have more than one possible charge. So I have chromium something oxide. Now what is my something? Well, I can calculate this. I have 3 oxygens. Each oxygen is 2-, because oxygen is always 2-. So that's 6-. My chromium has to be 6+. So this would be chromium Vi6. So chromium 6 oxide. All right, MnO2, manganese something oxide. Because manganese, I'm pretty sure, has multiple possible charges. Again, I can use my oxygen, my oxide here. I've got 2 of them, so 2 times 2- is going to give me 4-, so my manganese must be 4+. So IV there. So manganese 4 oxide. And lastly, I have H2SO3. So if I cover up my hydrogens, this is SO3, which is the sulfite ion. So the sulfite ion came from the us acid. Sulfurous acid, after it loses its protons, becomes the sulfite ion. Okay, so that wasn't too bad, I think. Now let's look at let's do this. Let's let me scoot over here, and I'll just draw a line down here, and we will write formulas for the following. Okay, potassium phosphate. Let's do It should be a lowercase b. I do apologize, but we'll just leave it as is. Let me see. I've got some more examples here. Alright, so those should be some good examples. So let's start with potassium phosphate. So I'm going to have K for my potassium. Now what's phosphate? Now it's not phosphide, which would be P, just phosphorus. Phosphate is in that table of, and I don't have it out here right now, but the table of polyatomic ions, and it is PO4 with a 3- charge. In order to compensate the 3- charge, we need 3+, and each potassium is plus, so we have K3PO4. Copper 2 bromide, so that's going to be CuBr. Now the 2 tells us that copper has a 2+ charge. Bromide is always 1-, so we would need 2 bromines or bromides to then counter the 2+ of the copper, CuBr2. Next we have dinitrogen trioxide, so that's 2 nitrogens, N2, and 3 oxygens, O3. Now magnesium nitride, MgN, but magnesium is always 2+, nitride is always 3-. So our least common denominator there, or greatest common factor, I guess, would be 6. So I would need 3 magnesiums and 2 nitrides. 3 times 2+ gives me 6+. 2 times 3- gives me 6-. Those counteract, or they counter each other. And then we have hydroiodic acid, where we have, because it says hydroiodic, the hydro tells us that we don't have a polyatomic, an oxyanion. We don't have a polyatomic anion, so it's simply HI. One that maybe I should show here is, let's do the following. Let's do ammonium perchlorate. No, not perchlorate. Let's do ammonium sulfate. Keep making those capital. I'm sorry about that. So I could look up and I could see my ammonium ion is NH4, the +1 charge. Sulfate is SO4 with a 2- charge. So I would have NH4, and I would need 2 of them in order to balance the 2- of the SO4. Notice what I did here. I put parentheses around my NH4 and then another subscript 2 here, indicating I have 2 of those NH4s. You can do that with a lot of different, excuse me, different ions as well. Let's say we have calcium carbonate. So calcium is 2+, carbonate is 3-. Calcium is Ca with a 2+ charge. Carbonate is CO3. Sorry, with the 2-. So that's fine. That's not what I wanted to do. I wanted to do here. Let's not do calcium carbonate. Let's do calcium phosphate. I'm trying to think of a few representative examples that can help you guys out. So calcium is 2 plus, phosphate is PO4 with a 3 minus. So I'm going to need 3 calciums to counteract 2 phosphate. So I have PO4, I have 2 of them, and then that gives us 6 minus. So I need 3 calciums at 2 plus each to give 6 plus to balance that. Alright, well these are some examples. Go ahead and work on those on the practice problems, and we'll be doing more of this in class. So until then, stay safe out there. Bye now.